2, we have less. We have 1, 2, 3, 4, 5. 1, 2, 3, 4. Notice the way I count my 5. Have you ever seen that before where I put the line through it? Okay, sweet.
They do it in prison.
Yeah, they do it in prison for the number of days they've left, yeah. There's 1, 3, 1, 4, and 1, 5. Okay. Right. Now we're going to look at well, we can put this is something called a tally table. I can put an additional line to a tally table and make it a frequency table, which is what we've already done in a way. We've just added up. What's the frequency of 0 occurring? It occurs twice. What's the frequency of 1? It was 13 if we add up this. That occurs 5 times. That occurs 3 times. This occurs once. Okay?
No, the 3 occurs once.
Oh, sorry. Yes, yeah, you're right. Okay. And that's a frequency table then. This has converted this from a tally table to a frequency table. There's actually something called a cumulative frequency table, where cumulative, which will come up maybe in one of the tasks on my maths, where you have to add up as you go along, which is kind of a strange thing to do. Maybe it creates a line graph. But anyway, there's 2 here. But now it says, what's the total of 0 and 1 together? 15. So I add these 2 to get that number. And now 2 plus 13 plus 5 gives this number. So an extra 5 gives 20. And an extra 1 gives 21. And an extra 1 gives 22. And an extra 1 gives 23. Which we're just adding up each section together one by one. What we really want to know is the total. 23. The total of both these is, what's the total number? That's just one way of something called a cumulative frequency table, where you add up as you go. So you know how many are less, like how many people have less than 3 siblings. Well, we know that that's 20. That's one use for that. That just comes up in one of the Maya Maths tasks, so I just thought I'd show you that as well. Okay, hopefully that makes sense. Definitely the frequency makes sense, how many times it occurred for each one. Now we're going to look at the 3 main ways of getting averages, or the middle of the data. And that's the mean, which we'll do first, because it's the one that most people do, which is what most people refer to as an average. And some people already alluded to how we do this. To get the mean, we add up the data, I suppose, each data point, and we divide by how many there were, which can be slow if we have the data set up like this. You've already done the schlock, good man. What'd you get? 1.5. Okay. If I add up all these, 2 plus 1 plus 3 plus 5, now you can use a calculator for this unit. Add up all of those and divide by 23. What was the total when you added them up, schlock? Can you remember? If it's was it 1.5 exactly? Oh, well then. Anyone have it added up for me? Okay, 1.5217. Okay, rounded. Can you multiply that number by 23 and we get what you originally had?
Well, if we add them up all together,
35.
No.
Okay, so let's look. How did this 35 number come about? You could just add up these. 2 plus 1 plus 3 plus 5 plus 2 plus 0 plus 1 plus 1, adding them all up together, and we get around 35. There's a quicker way to do that if we have one of these tables done. If I remove my cumulative frequency and do our, let's call this x and call this f, and then what is f times x? If you want, f times x or some version of that. The frequency times each data point. 0 times 2 gives 0. 1 occurs 13 times. So instead of having to add it 13 times, I can just repeated addition is multiplication. So that gives 13. 1 times 13. 2 times 5 gives 10. 3 times 1 gives 3. 4 times 1 gives 4, and 5 times 1 gives 5. And if I add these together, that's 23, another 3, 26. 26 and 9 is 35, and that's the same number here. What's this number mean? The 35, Van D? The 35 means that between us in the class, we have 35 siblings. That's what that number means. And how many on average and mean do we have? Well, if I divide by 23, we've 1.5217 siblings each. Or that's the most common number of siblings, which of course is not a real number. You can't get 0.5217 of a person.
Well, unless they're like split.
But yes, unless you're just slightly split, maybe around here. But don't think that's real. But that is, how do we interpret that? That means it's slightly closer to 2 than 1, but it's around between 1 and 2. If you were to ask someone in the room how many siblings they have, a good guess would be somewhere between 1 and 2, or 1 or 2. That is called the mean. That's what normally people use for the average. The mode is another way of calculating an average. It is another measure of center. Does anyone know what the mode is?
1.
Kiki? It is 1. Why?
Because that's the most amount.
The one there, the most. Which one was the most? 1 occurred the most often. So in R1, 1 is the answer. It had a frequency of 13 times. The mode is 1. So more likely 1 than 2. What's the median then?
In the middle.
You have to arrange them from smallest to biggest. Yeah.
Brilliant.
And then pick the middle.
Arrange. First. You must arrange first from small to big. Then it's the middle one. That is the median. Now, these are not arranged from smallest to biggest, are they? No, they're all over the place. They've already been arranged in this table for me. Now, if they're not arranged for you, you would have to arrange them. So if we had a number set like 1, 5, 3, 7, and 5, if this was our number set,
1, 3, 5, 5, 7.
Annie, so I would arrange it first, 1, 3, 5, then a 5, then a 7, and I would look for the middle number, Milo. And the middle number here is definitely 5. There's 2 either side of it. What happens if we have an even number of inputs?
You have to divide them.
Yeah, the 2 in the middle, it'll be halfway between those 2. Perfect. Half.
There's a 5 and a 5 in the middle. So you have to divide 5 by 5.
What's halfway between 5 and 5 is 5. No, it's not 5.5. Halfway between a 5 and a 5 is still on 5, yeah. What's halfway in our set of data, which I'll have to list them from smallest to biggest? What's halfway, but what's the halfway person? Which person in the list would it have been? Like this is the third person in the list of 5. If I have 23 people, what's the middle person?
The 11.5.
No.
The 11.
It's the 12th person. How do I know it's the 12th person without having...
23 divided by 2.
Well, 23 divided by 2 would give 11 and a half.
And then you add it up. And then you
But okay, when there's 5 people, what was the middle person? The third person. How did I get 3 when halfway of 5 is 2.5? The middle person of 5 is exactly the third person. That's person perfectly in the middle.
It would be the 12.
Well, you think about the middle person of 5 people is the first person plus the 5th person divided by 2 is one way. It's not there's no 0 person here. So this is 6 divided by 2, which gives 3, the third person. So if I have 23 people, it's the first person and the 23rd person. It's halfway between 1 and 23, not halfway between 0 and 23. Because you have a first person, not a 0 person. It's not halfway between 0 and 23, it's halfway between 1 and 23, which would be 12. So the 12th person in this list lies where? It's going to lie in, because the first 2 are 0 and the next 13 are 1. So if we put them in a row, we could test that if you want to. It would be 1. So the median in my one is 1.
Can I go to the bathroom?
Yeah.
Wait, well, like, if they're like together, how do you divide them?
You just look at the one in the middle.
If there's 2 in the middle, let's do another example where there's 2 in the middle, which is a great question. Let's say we have 6, 7, 1, 1, 3, and 4. Let's say these are our numbers. What is the median of this data? I would put them in order first. So 1, 1, 3, 4, 6, 7. What's the middle one? Well, I can do, okay, my middle, I have two numbers in the middle, 3 and 4. What's the median? 3.5. Halfway between these two. Plus them together and divide by 2. Yeah. If they're both 5? No. If you're in this space and you're also in this space, what's the halfway point between you? Well, you're still there. Okay, last one. Mean is your normal average, yeah, that you would do. Add them up and divide by how many there are. The range then, does anyone know what range is? It's a measure of spread now. It's not about the center, it's about how wide the data is. Kiki?
It's like the biggest minus the smallest.
Exactly. The biggest minus the smallest. So the biggest number here is what? 5. Not 13. That just counts up the ones. The biggest number is 5 in our list, and the smallest number is 0. So the range is 5, take away 0, which is 5. So that is how we calculate the range. What's the biggest number of siblings? 5. What's the smallest number of siblings? None. So the range goes from 5 down to 0, so that's 5 in total. It's just this times this. It's just a way of adding up the total. How many times did x is the number of siblings? What is its frequency? So 0 occurs 2 times, so f times. It's just one way of writing it. It's probably too complicated. Yes? Yeah, that's all.